So what I want to show you is I want to show you the sort of like the theory behind running a t-test. So if I do a t-test elements, okay, so a lot of the times you're going to have an assumption. For example, let's call it assumption 1, that your y is equal to beta 0 plus beta 1 times x plus an error term. Okay, this is an assumption. Let's say that you're further assuming, let's say another assumption 2, you're further assuming that the, and let me add here that the expected value of this is equal to 0. Let's say that you're assuming that the expected value of epsilon conditional on x is equal to the expected value of epsilon. Let's say that you're also assuming that, let's say all the samples are independently drawn. So this is implying that, for example, epsilon I is independent of epsilon j, right? You could add an extra assumption that says the variance of epsilon I is equal to the variance of epsilon j for all I and j. Okay. You could further add another assumption that says that actually this epsilon I is normally distributed. Okay. Centered around 0 because of this assumption here, and with a variance sigma epsilon square because of this assumption here. Okay. And you might further impose that actually these epsilons are all d, identically and independently distributed. Independently, we've already assumed from the A3 assumption, okay? So I'm setting up all of these assumptions here, okay, because I want to get to somewhere. We will call, in every test that we do, these assumptions here are going to be, these assumptions here are going to be my maintained assumptions. Or if you like, model assumptions, or if you like, some assumptions that are not going to challenge, okay? Not going to challenge these assumptions, okay? Here's a very common assumption that you're going to make, which we're going to call the H0. The H0 is, let's say, beta 1 is equal to 0, okay? If beta 1 is equal to 0, does the maintained assumption tell me anything about what beta 1 should be? Nothing. The maintained assumption simply tells me that beta 1 exists and it's a constant. But it does not restrict beta 1 to being 1, 2, 3, or 0 for that matter. Okay? So, what I will have, if I want to test this H0 assumption, well, here's how I'm going to do it. I'm going to come up with a test statistic. Test statistic. It turns out that in this particular setting, if I have this H0, the test statistic, let's call it T, will be equal to beta 1 hat minus 0 over the standard error of beta 1 hat. Okay, that's what this test statistic turns out to be. Okay, that's the test statistic that I'm going to use. Well, if I have to run a test on this, I have to ask the question of what is the distribution? What is the distribution of T? It turns out that this distribution of T will be T distributed centered around 0 with a certain standard deviation. So I'm not going to bother with the details, but what I'm going to say is that I'm going to make something centered around 0. I'm going to make it look very much like a normal, because I just want to focus on the big picture now. This is going to be the PDF of the test statistic. If what? Here's a big if. If the maintained assumption plus the H0 are true. Okay, that's going to be my distribution of my t statistic. Well, in order to make progress, one thing that I will have to do is to decide on the significance level. Okay, so look, if values are really extreme here, they're unlikely, and I might reject my H0. Note, I am never questioning my maintained assumptions, which of course will invalidate the tests if the maintained assumptions were not correct. So the step 1 here is to decide on a, let's say, significance level. Let's say the significance level I want is 5%. Step 2 is to decide on the alternative hypothesis. Because significance level together with the alternative hypothesis is going to give us the critical value in this distribution. Let me change colors and do a particular example. If my alternative hypothesis was simply that H0 beta 1 is different from 0, I'm doing a two-sided hypothesis test. My significance level should be 5%, which means that my critical values will be somewhere here. Let's say critical, T critical positive, T critical negative. Why do I need to put a positive and negative? Because it's a two-sided test. And because the significance level is 5%, this probability of being on these extremes is 5%. Okay, so this thing here is 2.5%. This thing here is 2.5%. Okay. Have I calculated anything with the data yet? Have I done any calculations with the data? No. I could do all of this stuff. Without crunching a single number. All I needed was the maintained assumption and the H0. Once I have maintained assumption, H0, I fix the significance level, I fix the alternative hypothesis, I can find the critical values by looking at the tables. Okay. Step 3 is we find our calculated test statistic. Okay. Well, let's say that our calculated test statistic comes out to be here. Let's call this T star. Okay. Let's say that our T star is here. T star. Once I find my calculated T statistic, there is two things. Well, actually, there's one extra thing that will derive from this. So step 4, I'm going to illustrate p-values. What's the p-value of that particular test statistic? Well, because it's a two-sided test, I'm going to have to mirror this. I'm going to try to mirror this somewhere here. So I'm going to say minus T star. And my p-value is going to be the probability of observing even more extreme values. So this bit here and this bit here is going to be my p-value. Okay. And my step 4 will be to conclude on this. Step 4 would be conclude. So for example, in this particular test, my calculated T statistic, T star, does not fall into the rejection region. What is the rejection region? The red region. This bit here is the rejection region. Okay, this bit here is rejection region. Okay, so what do I conclude here? Here's what I conclude. Here's the rightful conclusion. You would say, if the, or assuming that my maintained assumptions are all correct, it seems that beta 1 equal to 0 is not an unlikely event, or in other words, I fail to reject H0 is equal to 0 at a 5% significance level. So I fail to reject beta is equal to 0 at 5% significance. Okay? That's one way of doing it. Now, let me show you. This is the classical t-test that you've been used at finding. Let me give you a comparison of means. I'm going to do this fairly quickly. So my goal is not to give you the details, but to just give you the big picture. Imagine that you have sample 1. This sample 1 has, x11, x12, etc., etc., x13, so on and so forth. You imagine you get another sample. This sample could be a lot bigger. So x21, x22, xi2, etc., etc., etc. Okay? And what you'd like to know is you calculate the x1 bar, you calculate the x2 bar, and perhaps you might want to ask yourself, are these two averages statistically different from one another? Are these two averages statistically different from one another? Well, for this as well, you're going to come up with a t-test. The t-test is going to look something like x2 minus x1 bar. These are calculated from the data minus whatever your H0 says. Let's say your H0 says that these are 0, divided by whatever the standard error of x2 minus x1 bar is calculated to be. I don't want to go to the details how we calculate it, okay? And if your maintained assumption plus your H0 are true, this should be some t distribution. Okay? And similarly, even when you're comparing averages, you're down to the same principles. And I want to show you this in Stata and how you do this in Stata. But it is important that you have the underlying background. So similar as before, your test statistic now has changed, right? Because this is not beta 1 hat anymore, it's a different one. But the spirit of the test does not change. Okay? The spirit of the test does not change. So in summary, when you're doing t-tests, you're relying on the test statistic having a t-distribution. That's why it's called a t-test. A t-test can be done on a coefficient on a bivariate regression or a multivariate regression. It can also be used in comparison of means between two different groups, which we do quite often in this course. So that's it for